maintenance, air handlers. We've all been out there. We know how to do preventative maintenance on air handlers. But, a couple of things to think about here. One is the condensate system, so, flushing drains, so on and so forth. Air filters. This is our MVZ air handler with a built-in air filter. One of the things that you may not be familiar with that is right here in the return section is the return air sensor. Now, most of these air handlers are tied in with some sort of a room controller thermostat, but as a tip, if you're having trouble, it may be that you lost connection to that room controller, and then it will revert to this sensor.
Right, and this sensor also helps to adapt to the capacity that the unit's going to put out. So we want to make sure that that's always kept clean, that there's nothing blocking it, that it's able to sense and do its job.
Do its job, exactly. Now, we can also display faults on some of our controllers, our 2-wire controllers. Now, I want to caution you that a lot of people want to use conventional thermostats with an adapter, what we call PAC 444. If you're going to do that, nothing wrong with it. It works, but it does lose some of the functionality of the equipment that it's designed to have.
Right, so if there's an actual fault on the indoor unit,
you'll never know it.
You'll never know it until you get a 2-wire controller on there to be able to use it. So as a service tip, guys, if you do come across an old PAR 31, PAR 32, an old 2-wire controller, put it in your arsenal, in your truck, because what you're going to do is bring it out. And even though you have the PAC 44, you have a MHK1, you can still tap into the M1, M2 spot with the 2 wires and read your faults.
Yeah, just screw it in the 2 spots there, and then it'll show up right on the controller. So you never throw a functioning one away. Save it.
Correct.
Pass them out as service tools if you run across them. So one of the things we found out, I mean, obviously you can check your unit, check the blower operation. Now, instead of having a button to push, because this is no indoor unit, on the board there's an SWE, switch emergency, probably. I don't know the terminology, but that's what it is. So if you take this jumper as it's shown here, it's normally across the off, center and the off, and you jumper it to the center and on, that will start the blower as a continual blower operation. Now, along with checking the blower operation, we can also check if you've got backup heat connected to it. We can check that out. Now, the backup heat has its own power source, but and a relay in it, and that relay works off of 12 volts DC, and it's got a connector that's plugged into CN24-1, this yellow plug here. So what we found out and developed was that we can actually pull the connector off the board, as we see here. You can get an adapter for 9-volt battery, one of those clip-on things with 2 wires. And if you stick your little wires right into the end of the yellow plug, that 9 volts is enough to pull the 12-volt relay in, and you can test your electric heat. So very
simple. Check your amp draw. Yes.
Check your amp draw, right. Because what you'll find out is, again, different animal. It works off a controller, it's not on off. It's not a thermostat that's on off, like a regular heat pump thermostat. You crank it up to 80, all the stages of heat are be calling. Well, controllers don't work that way. Controllers will look at the difference in the set point, but it'll also wait and see, are we recovering without it? And if it is, it'll never come on because we're saving energy. So this is the only way you can check it, unless you're going to wait around an hour, and no company wants you to be doing that for preventive maintenance. So a little bit tip, 9-volt battery, you can go right in the end of the plugs, and so on and so forth. This is our little SVZ,
yes,
short duct air handler, and that has 2 ways that you can use condensate. One is a pump that runs continually as long as you have cooling or dry mode. That little pump's going to be running. And terminology's kind of changed a little bit. The last time I was with our air service manager, he continued to call that a lifting device because it's not really a high pressure pump. All it's doing is lifting the condensate up to a point where it can drain away by gravity.
Correct.
So I think I like that terminology. If your unit is high enough in a space that you can use gravity right from the bottom of the unit, you can disconnect that condensate pump and use the drain on the bottom of the unit. This little access hole is part of the cleaning process where you can get in there and check your pump assembly and the float switch, whether it's a service call or just as preventive maintenance. So for buildup in there as you would any other drain. Any comments on that one?
No, just so basically what you have there is you have a mechanism that's going to be your slinger pump, your lifting mechanism, and it also does have a float switch.
Right.
Built in.
Yeah, that's float switch is in a normally closed position that opens on a rise in water level.
Correct.
Ceiling cassettes, we can clean these out too, the corner piece off. I know you kind of developed this one process as far as accessing and flushing the indoor drain pan out.
Right, because this would, so if you were doing maintenance or you were doing service, I believe it would be like a P5 fault.
Okay.
Meaning that your lift mechanism has gotten, basically it can't pump.
Right.
There's a clog there. So this shows you how to get into this clog and do either service work or maintenance.
Yeah, so you can flush the drain system by with your access here. We give you a
Step by step.
Step by step. Take the corner piece off. Take the cover. The rubber plug in there. Pull that. You can connect a hose to it, and then from the back side in the access, you can force water in to flush it around that drain pan to get.
Right, now, in order to do that, if you're going to do that flush that way, you have to be able to get above the ceiling of that unit.
Right.
If you are stuck with that being encased and you can't really get above the drywall or you can't get above that ceiling, then all we can really do is work from the drain hole itself.
Okay.
And try to make sure that no slime or dirt has gotten in there.
Sure. Okay. So we've got one more slide or one more tech tip video that talks about diagnosing a power board. Pay attention to this because we actually had one come up that's actually in the presentation as we continue on. But here's how to diagnose it. This gets a little bit more advanced, but Doug's going to go ahead and roll this.
Hey guys, Jeff here with Mitsubishi Cooling and Heating. Welcome to another episode of Tech Tips. Today, we're going to be taking a look at a common problem where our noise filter board ends up going bad, which is caused by a shorted power board. Before we get into troubleshooting, let's take a look at the two boards involved in this problem and see what role they play within the equipment. The first board we have is called the noise filter board. The noise filter board acts very similar to a single pole contactor. It allows one leg of power to constantly flow to the unit, while the other leg goes through our relay. However, when it goes through the relay, it also runs through a parallel current limiting resistor. This allows voltage to still be on enough to keep, say, the lights on, but it doesn't allow enough for it to run the system. When there's a call for operation, that relay closes and allows full power to flow through the relay and drop out of the resistor. Now, the next board we have is called the power board. The power board takes 208 or 230 volts AC into it, and it converts it to a high voltage DC. This board is also referred to as the IPM or the inverter board. So let's take a look at our system here and see how when the power board shorts, it ends up blowing the noise filter board. After we've verified that there's full power coming into the condenser, either 208 to 230 volts AC, we'll want to make sure that we have that same power leaving the noise filter board. Check your wiring schematic for the exact terminals. In this case, we're using terminals LO and NO. In my system, I still have a full 208 to 230 volts AC. If we don't have full voltage leaving the noise filter board, that means we could have a shorted or a bad resistor. To check the resistor, simply power off the unit and then check ohms across the resistor. When measuring the resistor, you should receive about 20 ohms. If your resistor is blown, now it's time to move on and check if the power board is shorted. In our example, we're going to assume that it is, but let's see how to check the resistance across the power board. What you'll want to do is remove the incoming power wires to that power board. This will vary depending upon the unit you're working on, so please make sure to refer to the equipment schematic. When you're measuring resistance across the power board, in essence, you're checking to see if it's shorted or not. A good functioning power board would receive either OL or in some cases very high ohms like mega ohms or kilo ohms. If you receive very low resistance, 0.2 to 0.3 or up to 2 or 3 ohms, that means your power board is shorted. What we're checking here is a very specific scenario. The scenario is that the power board shorts and it backfeeds into the noise filter board and zaps its resistor. We hope you enjoyed the video. For additional information, especially wiring schematics, please feel free to visit our website at www.mylinkdrive.com. If there's a topic you'd like to see discussed in the future, please feel free to leave a comment below. Thanks for watching. Make sure to subscribe to our channel for future episodes of Tech Tips and Homeowner Help.
Okay, well, that was pretty cool. You know, all those little boards in there with all that stuff on them, it can be kind of intimidating when you look at it. But in reality, we don't need to know what every little piece does inside of there, as long as we know what it's supposed to do, whether and how to measure. So that was generic, but wouldn't it be nice to have a step-by-step process to go through to check something like that? Well, in reality, we do. Remember I said earlier that there's a service manual for every piece of equipment out there, and we're going to get into that. So let's just move ahead here. I just want to get into here's some troubleshooting basics, and you may want to, I would recommend take notes on this. And this is our process, and these are some of the things we need to be familiar with and look at.
Well, Jim, the one thing I will say is this: tip number one, voltages, AC
Right.
and DC. You got to be able to read high and low AC and DC, and you have to be able to read communication voltages, which is normally going to be DC voltage.
That's correct.
That means, guys, that we need the proper voltmeter.
Right.
Okay, too many times I'm getting guys calling us, and it's like new techs run out. They go to, I mean, I'm not picking, but like a Harbor Freight or a Sears Hardware, or you know whatever, and they're buying the least expensive because it's a big investment. Voltmeter. Your voltmeter must have AC and DC.
Correct.
And it should be rated up to, I believe, probably about 600 volts.
It should be 600 volts. It should be UL listed. It's easy to buy cheap stuff, guys. You know.
All I'm just saying is, if you don't have DC readings on your voltmeter,
right, gotta have.
Yeah. I mean, the other day a guy tried calling and all he had was a lighting. The little bulb.
Trouble light.
Trouble light.
I forgot.
That's not going to help.
Yeah, that's not going to do anything. And just as a side note to that, as technicians, we're investing in ourselves, and that means we need good equipment, good tools, proper tools. That becomes very, very important on the installation side of Mitsubishi, which we cover in the 2-day class. I always say that Mitsubishi is a high quality, highly technical piece of equipment, but we need high-tech technicians working on that with high-tech tools sometimes. So some of those high-tech tools are the ability to access some of the resources that we're going to show you right now. We're going to lead you step by step through that. So we've got our voltages. You've got to understand how to measure voltages, both AC and DC. We've got to be able to understand how to measure resistance, because we have a lot of thermistors in our equipment that need to be checked out. We do that with ohms. Observations, again, observations. What's going on in the whole system? How's it laid out? What's the system look like? How was the installation? Is it tilted? So on and so forth. But when we get into the service side of things, we're also going to give you clues. We talked about, is the outdoor unit, we've got a call for cooling or heating. Is the outdoor unit running? Could it be cycling on and off? Or could it be running, but yet not performing properly? All those are separate clues and observations. You need to know what it's doing.
And that being said, Jim, I was going to just say, you got to remember, guys, okay, we have fault lights on the indoor units.
Right.
We have fault lights on the LEDs on the outdoor unit. Okay, we do get flashing codes. Some of the MXZ 8C48, some of those hyperheats are now putting out a digital code,
Right.
like an 11 or a 1504.
Mm-hmm.
You know, thermostats will put out a P something, you know, like, or a U something, usually the 2-wire controllers. So all I'm just saying is this, you've got to start looking when you're troubleshooting at every piece of equipment, because each one of them may be giving you a different fault or a different thing. So inside, is there a flashing code? Oh yeah, I didn't even look at that. That's going to give us a clue. Right. Is the branch box giving us, is there lights even on?
Right.
Okay, is the outdoor unit lights on? Is there a fault code? Along with, it comes on, it goes off, it comes on, it goes off, or it doesn't do anything.
Right.
Those are all observations, and we have to gather those if we're going to start servicing it.
Right. So voltages and observations. So along with that, resources. The big one is what we talked about, was a link drive. So what I'd like, and I'm struggling here just a little bit, because normally we've got a class full of people, I've got a presentation, and everybody has a device in hand, whether it be a phone or a tablet. We quite frankly recommend that you have at least a tablet where you can read a good amount of it. It's really hard to follow any website in depth on a phone. If that's all you've got, I would recommend turning the phone so it's horizontal, that you can read more material.
But I think as we go through this, Doug's going to be able to put that website up, so you'll be at least able to see what you normally would find on the website, and he'll navigate that for you on your screen so that you can see how we get to it. But what we're doing now, what's that?
Not yet.
Not yet. But what we're doing here, you can replicate on your phone, on your tablet. Your service manager can do it back in the office.
Yeah.
Which is all what somebody's going to do on Tier 1 help.
Well, yeah, and we'll talk about that very briefly. So mylinkdrive.com will get you started. We'll show you that. And then inside My Link Drive is also another real help called M&P Troubleshooter. And we're going to bookmark both of those pages so that they're readily accessible. On mine, I just created a folder under my search provider, or whatever you call that. I'm not a technical guy, so, but anyhow, but I know how to make a folder, put what I want in there. So it says Mitsubishi, I open it up, it's My Link Drive, M&P Troubleshooter. So those are our big resources to help us troubleshoot. After that, so the process is going to be, you make your observations, you're testing your voltages, and you see what's going on, indoor, outdoor, controller, maybe branch box. What's there? Make your observations, what's happening. Go to Link Drive or M&P Troubleshooter, and M&P Troubleshooter is usually the best one to start with if there's something there for your particular unit. Work through the process. Most of the time, it'll lead you right to what's going on. If you can't follow it, now we as DSGs are available. There's 4 of us here at Ferguson, and with the phone numbers been provided for you. Call us and we'll help lead you through. But we, like John was saying, you need to have the proper tools. We need to know the outdoor unit, the indoor units, so on and so forth. And so it's always a good idea, maybe just take a picture of the labels, that way you got the model and serial number. And every once in a while, I'll ask somebody to send me a picture of what's going on. And that leads me to a side note, but John, what you think, we have a process here at Ferguson North called Help Lightning, where it helps us where we can actually do a merged reality tool with your phone, where we can look through your phone, through your camera, and see what it's seeing live. And in some cases, we can even reach in and say, no, don't test there, test here.
So it's basically, so if you were to call us and we were to do this, and one of the things is it's sometimes frustrating because I'm depending on you to verbally describe what you're seeing. And it's like, well, I'm looking at the board, and okay, but on the left-hand side, do you see CN 105? No, but I see a CN 32, or I see these blue wires. Is this what you mean? And soon the level of frustration between you and me starts to build. So what we found very helpful is there's a new program. So I will actually say to you, listen, we're going to hang up very shortly. You're going to get an invite on your phone to click onto this link. In your text messaging, you'll click onto that link. At that point, we will now FaceTime. Then I will say, okay, I'm going to offer you the help that you're looking for. When I click that button, all of a sudden now I'm seeing the backside of whatever your phone is looking at.
Yeah.
Now you're going to show your phone to the electronic panel, and now I'm seeing it on my side on my pad.
Right.
And then you're looking at it, so you're like standing over my shoulder, looking through it and seeing what I'm seeing. And then all of a sudden, I can put a pencil, a probe, a screwdriver in there and say, no, I want you to touch that particular thing. Oh, those numbers are so small, it's hard to see. I can't read that. But I now am looking on a blown up wiring diagram, can point it out to you, show you which wires position 3 and 5 are running voltage on. And I'll put my probes right in there, and you'll actually watch my hands come in through your screen and look at it and go, okay, I can do that then. Hold on, I'm going to put the phone down for a minute, and you go and do it. Or what's really best is if you have a partner, he holds the phone, one guy does the work, one guy holds the phone, and then we just fly through this, and it's like I was just in the attic with you.
We're there. Yeah, we're there with you. So it's a great asset. We found this to be a great help in several instances so far. So, but yeah, John alluded to it. We need you to hold the phone steady, or maybe better off, having somebody hold the phone so that it's nice and calm, because we hard to keep track of stuff, especially if we're telling you where to touch. The phone's moving all over the place.
Because they've all been with it. You're in a dark basement, you're in a dark crawl space, you got a screwdriver in your mouth, you're trying to hold the phone, you're trying to hold probes. I mean, we only have 2 hands.
Yeah, exactly. So anyhow, so we're your first line of tech support. Without getting into too much detail, it used to be Mitsubishi, put their number out there and you call that and you got right to technical support. Mitsubishi's growing in leaps and bounds, and everybody now calls that number for everything. So therefore, that's changed a little bit. And if you do get through, they're going to make up a case and put you in a holding pattern. And not nice to say, but you may or may not get a call back that day. If you're fortunate, you may, and probably will, but may not be. You're there on the job. You don't want that waste of time. So call us first. We'll lead you through everything we can. And then if we can't figure it out with you, now we will make up a case. We will need to know model, serial number, like I said, of all the equipment. I need to know the address of the service call. I don't need the customer's name, but that's one of the things that they want in there. And then we will make up a case and get a number. I'll call you back, or we will call you back with that number. Now, when you call the number, which is now provided for you, you'll have a case number. So it'll ask for a ticket number, case number. You enter that number, and you will immediately go to Tier 2 tech support, not the Tier 1 that you would get when you called in. We will document what we've done already, what the voltages were, certain locations, and they, with their years of experience of working Mitsubishi only, then will, as needed, move you up the chain until we come to a resolution. So that is the smoothest way for you to get technical support in the shortest amount of time. So, but again, with the resources we've given you, you may not call us for quite a while. So anyhow, so what we've done is we've actually taken some actual calls for Mitsubishi technical support and put it together. And We're going to give you some examples, but what I'd like to do first is to show you the resources and how to get around within Link Drive. So I believe Doug's going to go to Link Drive now, or what we would do is maybe go to Google and start out. That's what he's done, and type in something like My Link Drive. Okay, so any search engine will get you there, and you're going to go right there is My Link Drive, and you click on that, and you'll get this screen where you see all the flights. Mitsubishi is an international company, so we're only concerned about, as far as I know, unless this goes viral or whatever they call it, newfangled stuff these days. Right now, for our local area, we're dealing with the United States. Okay, so you're going to click on the United States flag. That's going to bring you up to the United States Link Drive site. Now, once we're there, before you do anything else, what we want you to do is bookmark this page. And I don't know how every system does that. I believe Doug's going to do that by clicking on the star. We've got My Link Drive. And here's where I would probably do a folder that said Mitsubishi. That's what I do. Now I have a folder that's labeled Mitsubishi. I can find this easy with the other bookmarks that I have. Okay, so now it's bookmarked. Now we've got My Link Drive, and look at everything that's there. We're on the home screen now. We've got, we're looking at, we will look at M series. In fact, why don't we go to M series, Doug? And because the first thing I want to do is go to and find the M&P troubleshooter. It's not listed under every piece of equipment, but I believe on wall units, I believe under GL, that's an easy one to get to. Any of the GLs. Now, look at what's available to you. Accessories for it, the application manual, compatibility. You want to know, does this controller work with this? The engineering, installation manual. There it is. So what I always tell people is, look, if you're going to do an installation of one of our products and you've never done one before you ever go out there to get the installation manual, don't wait for it to open up and sit it on the job. You've got it. You can read it at your leisure ahead of time. The operation manual for the customer, a parts breakdown. But look at service. Oh, here we go, M&P troubleshooter. So click on the M&P troubleshooter, and again, before you do anything else, bookmark the M&P troubleshooter, put it in your Mitsubishi folder, and now you have the two greatest resources for troubleshooting that you will use most of the time. So this is what you need before we ever need to call for technical support. Okay? So, Doug, I don't know, you may want to just leave them up there, because what we're gonna do is go through here, and we're gonna start out with an example, our first example. So what we've got is a service scenario with no cooling. It's a one-to-one system, and look at that, it happens to be a GL MUZ GL with an MSZ GL. So we've got no cooling. Now what is going on with this? So you're out on a job. Again, we've located the controller, we've located the indoor unit, we know where the outdoor unit is, and the first thing that you take notice when you look at the outdoor or the indoor unit is it's flashing. There's a blinking light flashing 2 times. Okay, well, what's that mean? Well, we can go to, what I recommend is going to the M&P troubleshooter first, bringing up that GL unit, which we were just there with all the answers somehow, as we go through here. So let's look at that was an MSZ GL15NA, for all the MSZs with a 2-time flash. So as we go through there, we can find a 2-time flash. What's the problem? Well, right there on the first line is indoor thermistor error. Okay, well, that's good. We've got an indoor thermistor error. How many are there on this system? Well, we've got to start looking down there, because as it turns out, we've got 3 of them. Which one's bad? How do we determine which one's bad? Well, that's pretty simple. A thermistor changes its resistance. That resistance is the key, based on temperature. So all we need to do then is measure the resistance of those sensors. But we've got 3 of them to check out. So we're assuming that the room temperature is 70 degrees. And if we start measuring those 3 resistors, we find that RT11 is measuring 15.47 mega ohms. RT12, resistor 12 is 12.12 k ohms. Resistor 13 measures 12.09 k ohms. Now, we've also got a chart that says indoor resistor 12, 13, and 11 should all be the same at the same temperature. So John, what's that tell us? Out of those three, which one's off?
Probably RT11 would be off.
Has to be RT11. In fact, in all likelihood, RT11 is probably open, but if you're holding your leads onto the ends of the wires, even though it's open through the resistor, the meter will pick up the resistance of your body from hand to hand, and you'll read the resistance of your body, and lo and behold, it actually shows up about 15 mega ohms through your body. So we know RT11 is bad. But what's RT11? Which one's RT11? If we continue down through the, sorry to make you jump around like this, Doug. And I didn't get it. I'm behind too.
Well, it is going to be the return air sensor. I believe that's what it was marked as in the link drive.
On the link drive.
It will tell you that RT11 is the return air sensor, which we know then is on the side of the cabinet behind those slots.
Exactly.
Of where we're bringing air in. And so one of the things that I thought was interesting too is that in the link drive, it also tells you what the symptoms are going to be. So this unit is going to come on and run for 2-3 minutes and then be off and flash this code. Run for 2 or 3 minutes and then flash this code.
Okay.
And so realistically, there's going to be no cooling, no heating taking place in that room because the unit doesn't know what percentage or what capacity to give you.
Right.
Because the sensor is now faulty.
Right.
Or open.
Yes, I believe the link drive or the MMP troubleshoot is back on the chart. So we know that if you page down that we know it's the RT11 is the
room temperature
thermistor right there. Okay. Now, if we were to continue a little bit further on, if all those, so we've got a 2-flash that's telling us we've got a bad sensor. But what if you measured all 3 sensors and they all ohmed out about the same? What would that mean? Well, if you were to page down a little bit further in the MMP troubleshooter, and there's a lot of jumping around, and obviously this is all new to this, but we would find out that if you were to continue on, it's going to tell us that if the resistors don't check out bad, but yet the board's telling you it's got a bad sensor, well, then it's got to be a bad board. We need to replace the board.
And the beauty of what Doug is scrolling through here right now, guys, is that what you're seeing is you're actually seeing the board, seeing the locations as they're marked, so that you can pull that out and it actually shows you where it's at
Where
on the board.
exactly it is.
Right where it's at, where they're marked, where they're going to be.
Yeah,
Okay.
right. Yep.
And then as we were to continue through the step-by-step process, it would then tell you after you've located these, after you've ohmed them out, if for some reason now all of them equal, then it's a faulty board.
Right. The board is not getting good information, or maybe a connector issue, but the resistors are fine. The board's still saying I've got a bad sensor. I'm flashing 2 times.
So step 4, which Doug is highlighting, it says if a thermistor is outside of its range, open or shorted, replace the thermistor. But however, if all the thermistors own properly, replace the indoor board. Right. There became a very simple service call where a consumer says, I have no cooling. You walk in, you make your observation of everything, you go through and you go, the only thing that's giving me a fault is this indoor unit with a 2-flash. What does it mean? Oh, let me get my phone out and go to link drive.
Right.
Let me go to this particular unit, go to the MMP troubleshooter. 2-flash means this. Oh, I'm ohming out sensors, and you've just discovered your problem.
How easy is that? It's a step-by-step process. So that's what we're trying to get across, is the information's available, but how do we find it? Okay?
Why don't we do another problem just so they can see
Sure.
the ease of this?
Yeah, we've got nothing but problems left.
Yeah.
So, and challenges. Anyhow, so another no cooling call.
Is somebody on mute?
what I've done here is just to keep it simple. We're staying with the same system, but no cooling here also. But now our observation, after we've looked at the indoor-outdoor units, controller, calling for cooling, the outdoor unit is stopping and then restarting every 3 minutes. That's our observation. Now we open up our cabinet, our access cover, and obviously we're going to be careful about voltages, not sticking our hands in here. But this is why we don't reset or, we don't kill power right away till we.
And with that, let me just say this too, guys. The boards are sometimes the boards are mounted upside down. Okay, and so guys are like, well, where's this fall? I have found that if you go to where your L1, L2 is, S1, S2, there is a opening above that. So and this is how bad I am. I gotta close the one eye, cover it. I look through the hole with the other eye, and you will pick up the flashing red light. Because if you look into a dark room, you know what I mean? And there's only one light at the end of the room. That's what you're kind of looking for, you see. So don't totally disassemble it.
Right.
Because then you're going to let that light bleed in and you may not see the light. So with the front corner cover open, I just take the electrical cover off. I cover the one eye, tilt my head, look in, and I look up towards like about 10 o'clock on a clock.
Right.
Look up that way and you're going to see a red blinking light. And that's how you pick up the 5 flash, 2 flash. You don't have to try to get the board, flip it over, look at it. It's going to take you a long time. Plus, plugs pull off, and the electric is dangerous.
Yeah, we don't want to be doing that. And if it's a bright day, like John's talking about, you may have to struggle in some of our units to find that. I've been known to take a dark drop cloth and form a hood, like the old photographers, and cut out as much light as possible so I can look in there and see that.
So going back to it, we have an outdoor unit that stops and starts every 3 minutes, 5-time flash. What is the problem? According to the link drive.
Okay, so we're going to go now to the outdoor unit, which would be MUZ.
Okay, and then we're looking at our tonnage, which is less than 20, so we're going to go to a small unit.
Yep.
The board is pictured there. It shows you where how the board's upside down. It shows you the arrow as to where that light's going to be. We know that the unit's running on and off, and we get a 5-time flash.
So 5-time flash means what? High temperature protection, as it shows there. If we read through, over 158 degrees. So what could be wrong? If we start looking down under troubleshooting, you can see that the background right there. It's over 158 degrees, and here's what we check.
And knowing what mode we're in, so for cooling mode, make sure the outdoor coil is clean and has good airflow.
Right. And in all likelihood, that's going to be your most logical, most probable cause, is we've got a dirty outdoor coil. There are some extenuating circumstances. If you look at that and the coil's clean, or you do a flush of that coil, clean it off, reset it, and it comes back, well, then we have to go further. Some of the other things it shows you is, one of them, we have a rare request to put your gauges on, check the charge. We can check the superheat at the compressors, what it's telling us, but then we also have cooling operation below 64 degrees. Well, why might that be? And we're not going to dwell on it too much, but one of the others, if you want to really understand that, is M-Series equipment is not designed to provide full cooling in low ambient conditions. One of the other tabs, many tabs on Link Drive, is something called application notes. So there's a pretty good detailed explanation of why not to use M-Series equipment in a low ambient setting, such as trying to cool off equipment in a room, when it's 40 degrees out. That's not an application. It's a misapplication for M-Series equipment. It's just not going to work right. So App Note 1035 talks about that.
So where you would see that and where that could be a possibility would be this. So a dentist office, doctor's office.
Sure.
Many times for the cost of the equipment, M-Series is put in there. And they always say, oh, it's only going to be used in the summer, the air conditioning feature of this. But you know what? Given October, a November day, tomorrow morning, it's going to be down to 30-some degrees. A doctor's office could have patients starting to come in, internal rooms, yep,
Yeah.
and they're running air conditioners.
Right, right. So, could it be that this has a bad thermistor and it's given us bad information? Well, if you were to look around, you would find out that no, that's not the case, because it's actually given us a temperature. It's saying, hey, I'm over 158 degrees. That has to be accurate for it to know that. So if you were to go back and look at the one flash for this piece of equipment, you would find out that, we looking at the right one?
Yeah, there's
I
not
could be looking at the wrong, not sure what's going on.
Doesn't it have to go to the service manual?
It could be that it's in the service manual. That's the other thing. So the M&P troubleshooter is much more generic than the actual service manual that is also available in the link drive. So you would be clicking on the service button and then go to the service manual, but it may be 150 pages long because there's all kinds of information in there. And towards the end, we get into the troubleshooting side of it. I'll tell you what page.
Well,
that's
and I was
on.
going to say this too, is when you look at the M&P troubleshooter, there are 3 different categories as to whether the outdoor unit does not run, does run, or it cycles on and off. Okay, so sometimes if I'm getting a flash code that doesn't match the is running, is not running, I search under those other topics.
Right.
And then it's like, oh, you know what? It's been longer than 3 minutes. I guess it isn't running.
Right. What I realized, Doug, is it actually would give you a outdoor unit not running because it's saying, hey, this coil's too hot, shut down. So at that point, it wouldn't be cycling on and off. Again, observations. So the outdoor unit would not be running, and then it would give you a one flash and it would say open sensor. So again, we're muddling through this. It's much easier to let you page through and find this stuff, at least for me, maybe not for you, but this is how you learn, by doing. And I had guys in class, after we do a few of these, they come to the conclusion, all the information's there. It's all, I'll never forget the guy that
Hey,
said,
Doug, can you put that up a little bit higher for a minute? Scroll up. Scroll up. Keep going. Oh no, this one doesn't say this. Okay, so if we were to go back to the original fault that was here originally, and the thermistor, not the thermistor, but the dirty coil situation, and if
Right.
you didn't have that, one of the things I did want to bring to your attention was this. If you were to go back to that page and look at that, it does say, like if you've done step 1, 2, 3, 4, and we can't resolve the issue, it then says to call Mitsubishi's technical support. If you choose to call those people on that because you've now done tier 1 support yourself.
right.
Okay, call them up, say I'm on the job and I have just been on the link drive. I used the M&P troubleshooter. Here's my fault. I did steps 1, 2, 3, and 4, and it now told me to call you. That will push you towards the front of the line as far as tier 2 now
Right.
getting back to you because you already did what tier 1 did. If you don't tell them that, then you may actually get somebody on the phone who's going to read this to you and say, okay, we need to do, whoa, I already just did that the last half hour.
Right.
Oh, you didn't say that. Let them know up front that you're working with the M&P troubleshooter
Yeah, that's a
so
great
that you
tip.
can move forward.
Great tip. And the same would go if you're calling us.
Correct.
Let us know that you went through it. So, okay. Let's do another one. In this case here, we've got an MXZ 3C30 NA2. It's got 2 units inside, two 15s. We're going to stay with the M&P troubleshooter. So but here's our observations now. In this case here, the compressor runs a short time. The outdoor fan motor doesn't start. After 3 minutes of being off, the compressor starts again, tries to run. Again, no fan operation. And now we start taking voltages, looking at voltages. And we realize we got our 230 volt to the unit. In all reality, the compressor probably wouldn't try to start or wouldn't run without it, but we always check. You just get in the habit. test L1, L2, S1, S2, S2, S3 DC. Okay, just get in that mode. Okay, we've taken the cover off, obviously, and our outdoor board at this point, there's 2 LEDs there. We observe the yellow LEDs off, but the red is flashing, and you count the flashes, it says 13 times. You're probably checking that a couple times, because I usually lose count about flash 8 or 9. So I always check, make sure it really is, what it says it is the first
So
time.
then what we want to do is go back to the M&P troubleshooter.
Back to the M&P troubleshooter, and
We're going to try
what's
to,
that telling us?
so we go to the M&P troubleshooter. We have, you said that yellow is off and red is 13 flashes. So that's that second grouping. And it says, well, of course, what we suspected, that the condenser fan failure is
The
there.
fan wasn't running,
Right.
so
That's the failure.
that's the failure. So we're going to just order a new fan motor and go put it in, right?
No.
Oh, but wait, there's more?
There is more. Because one of the things, guys, that's this. Okay, and one of the things that you're going to learn with Mitsubishi, and we're dealing with an issue right now with a consumer and a company, is this. If you determine, and we would say, oh, okay, I'll order a new motor. Check, do one more step and ohm out the board, or check the board, or check the wires, check all of the other things, because nothing will bite you more than to go and put the motor in, and the consumer's kind of standing over looking and saying, are we going to get heat on today? Are we going to get heat?
Yeah.
And then it's like, oh, wait a minute, it doesn't work either. But this is a brand new motor. You said I needed a motor.
Right.
And you put the motor in, and now we do the next test, and it's like, oh, now I need to order a board. I'm not waiting another 2 weeks. This is ridiculous. Give me your boss's number. And
Yeah.
that's where it goes.
Right. Yeah, or worse, oh, I got a bad motor from Mitsubishi, I got to order another one. And I've been there where there's like 3 things been replaced, one right after the other of the same, and there was nothing wrong with the first one.
Right. And we could have discovered all of this at the very first service call.
Right.
We've got to take it one more step.
Yeah, please, especially when we get into these products. Okay, so what we're going to do then is we're going to follow the troubleshooting steps exactly. We're not going to go through it here, but what I want to stress on it is there's a procedure to go through and see whether it's the motor or something else, how to determine if it's actually the motor. You must note when is the power to be on. So what I like, I mean, if it was printed out, I would make a check mark next to it. You have to keep track of it mentally. But, so it's going to tell you, turn the power off or turn the power on. Do this. In this case, the next step's ohm out the motor. How do we ohm out the motor? Which wires do we ohm out? And I'll guarantee you, you're going to need your needle point leads for your meter to ohm that motor out. In this particular motor, there's a feedback because they're ECM motors, which you're well familiar with, and like some of the other motors you may be familiar with, they not only does it get a signal that's saying run at this speed, but there's also feedback from the motor back to the board that says, I'm giving you what you asked for. Here's my feedback. And there's ways to check that. I've seen motors that will get the signal and they'll run, but they won't send the feedback back out of it. It'll show up as a fault. We're only going to replace what's actually bad. So John had a great point there, whereas we don't stop just because step 1 says you've got a fan motor failure, because it may not be the motor itself. Just like that thermistor. Maybe the thermistor is reading good, but the board says, I don't see it. Okay? So, does that make sense, guys? I hope so. I mean, we're probably not getting any. I haven't seen a chat question come through. At least I see no rate. I've got somebody waiting here. So if anybody has got any questions, type it in there. Or unmute it. This is real informal at this point. So
Maybe we'll do one more scenario then for that.
yeah, we can do one more. We'll probably do 2 because this one's pretty simple. This is one I personally received. PVA P-Series air handler. It was using a PAC 444 adapter to a conventional thermostat. And I got a call in desperation from an installer on the job. He says, I need help connecting a boiler to the system. Okay, what's the rest of the situation? Well, I don't know. I got to connect this boiler. Well, I need information, okay? So if you're going to call up, give us the information. Are we looking to put a hydronic coil ductwork above the air handler? Are you trying to control hydronic heat in this application? Basically, what we're telling you is when you get into a specialty application, plan it out ahead of time. Read the installation manual. Know how you're going to be doing it. This poor gentleman was on a job. He'd already been an hour trying to skim through the big manuals and put it all together and figure it out, and had no clue. And obviously, it's probably 4:30 in the afternoon. He wants to be home by 5. So look at it ahead of time. The answer to that actually, it turned out to be there's a special connector relay. I think it's connector 24 relay something or other that can be plugged into the board of an air handler, and then you have dry contacts that you connect to go to a TT or something like that, without getting into too much detail. Here's another one that's actually pretty simple. An actual case came in. It was an MUZ one unit, new installation, indoor unit won't power up. Okay, observations, voltages, observations. Outdoor unit, get 240 to the outdoor unit, L1, L2. S1, S2, 240, just like we talked about. Whatever's coming in should be going out. S2 and S3 wasn't reported, but what was stated was there's no fault codes observed. At the indoor unit, no lights. There's a good clue. If you don't have any lights at your indoor unit, now we look at our voltages. In our case here, the S1 and S2 indoor was 0. Now wait a minute, we had S1 and S2 outdoor. We don't have it indoor. That could be a couple things. In this case here, when he went to check S2 and S3, he found out there was 240 volts on S2 and S3. Now wait a minute, we talked earlier, what are we supposed to have on 2 to 3?
12 to 24 volts,
right.
DC volts.
Yep.
Right, and here we have the high voltage on this. So we basically know, and this oftentimes happens when there's more than one guy working on a job, wires were switched,
Right.
improperly wired unit. Remove the wire, go outside, kill the power, wait for it to bleed down, pull the disconnect, whatever out there, switch the wires around inside, plug it back in, and guess what? We now have operation.
That one was pretty simple. Guess what? We didn't need the link drive. We didn't need the MP troubleshooter, because that's just basic checking your voltages.
We knew, and as you learn, you start to understand S1, S2 should be whatever your incoming line voltage is.
Right.
And then 2 and 3 is 12 to 24 volts. And that 12 to 24 volts should be jumping around.
Right.
That tells us that we're communicating. So when we see 12, 17, 19, 21, 23, 5, 6, 12, 9, all of those numbers going across my voltmeter, I know what's happening is like signals going out, signals coming back, signals going out, signals coming back. If it's steady, then we've got a problem, and we can help you diagnose that.
Something's dead somewhere.
Yes.
So, and when we do the 2-day class, we actually show that you do need a decent meter for that in order to test that communicating voltage. Some fairly inexpensive digital meters, it may be showing 0 and getting fuzzy, and it may show another voltage. But with a good meter, you can actually watch that up and down, just like on an analog meter. If you got a decent analog meter, you'll actually see that needle swinging back and forth, and that's what a good digital meter should show you.
So, like, what I'm hoping here, Jim, is this, and with the guys that are there, I know some of the audience, some of the guys are newer to the Mitsubishi products.
Right.
Okay, I've heard from you prior to this class, how do I get in, how do I observe it, okay, and we've helped you on that. If this wets your whistle at all, as far as this, and you have an interest in learning the product,
Right.
Okay, this coming fall, hopefully we will not be practicing social distancing. Okay, be able to have a class where you physically can come here. really talk to your employer or employer. Think about sending some of your guys to the 2-day class that we will be offering quite extensively in the fall.
Right.
Okay, that is 1 day of knowledge as far as book learning, where we will take sensors and we'll tell you those temperature splits and those differences and how everything works, how everything kind of comes together. And so as an install, you evaluate, man, what I do here on day 1, 2, and 3 will affect the way this thing operates the rest of its life.
Right.
And then we'll help you with the service side of it on day 2. And then there's actually hands-on. Okay, we have operational pieces of equipment here. We will check those voltages. We will run through the process and we'll run through this troubleshooting. You'll bring your pad with you. You'll be able to find faults, create faults, resolve faults
Right.
here in the 2-day class.
Right. If we were to be able to swing the camera around, which we can, you would see a room full of equipment that's live and operational, and we can go through any of them and, you know.
And depending
check
on where
anything
you're at, we will have this location ready
Right.
in the fall, and we will also have our Lewis, Delaware
Right.
location available for any of those that are, down below, in the Delaware, Maryland area.
Okay. Anybody have any questions at this point? We do have a question coming in, I believe.
Yep. Do you have the address for the flexible duct course that was spoken about earlier in the presentation?
I found it by just Googling proper flex duct insulation. It's in the slide. I'd have to get back to it. If you want to send us an email, you could. But I believe it was flexibleduct.org is one of them, from what I recall. We're going to stop at this point. So let me go back. Doug, maybe you want to take this offline.
Move the water bottle.
Hey, we're professionals here. Yeah, we're used to doing this all the time. And I keep getting blinded by going in the wrong.
Should we go back through the PowerPoint to find that?
Yeah, if you can, if you're able to do that, yeah. Doug
We'll put that back up again. Is there any, guys, at this point, if you want, we're winding down, as you can tell.
Yeah.
You can unmute your mics.
Yeah.
If you want to ask us a question, something about install, something about the service, maintenance, we'll take a few questions and finish up in the next minute or two if there's no
I
questions.
didn't mean to do that. I hit the wrong button and everything went dead. So we're going to rely on Doug at this point and the projector.
And there it
You
is. It's
don't
on the
need
screen
mine
for you
now.
now. It's flexible air duct. So I'm looking here. It's called airductcouncil.org.
That's one of them.
That's one of them.
And I believe they're an inner
Or flexibleduct.org, because I see an email address, Air Duct Council.
and it's a great thing to go through and learn how, like I said earlier, how to install it properly, and then how obvious it is that most flex duct runs are put in incorrectly.
And honestly, so guys, listen, so if you came to the 2-day class, Mitsubishi would tell you, really, they want hard pipe
Right.
and sleeving.
Right.
Okay, but we also know where you guys live.
Yeah.
You know what I mean? And it's not going to happen all the time. So we understand that. So if we're going to use flex, we're already behind the 8 ball. So if we're going to do it, let's make sure we do it right to the best of our ability to not hinder the operation of the equipment.
Right.
And again, we go through all of that in that 2-day class.
Yeah, and maybe, because of, what's going on right now and you want to learn a little bit more about Mitsubishi, we have done a 4-hour
Install class.
review of installation best practices is a good title for it. That's available on YouTube. Again, get with your TM as far as how to get there.
Well, basically, I think you would go to YouTube and you would search under Lion North.
Okay.
Ferguson HVAC North.
Oh,
Ferguson HVAC North.
right.
If you do that Google search, if you do that search in YouTube, you will start to see the file of videos that we put together. And this one class today will soon be on there.
Right. And if you're bored sitting around at home, there's other videos that have been done that, on other brands, namely Train American Standard.
Right. And Mitsubishi has their learning channel also.
Oh, my word. Yeah, we didn't even talk about that. Mitsubishi, not only do they have the tech tips, they have a learning channel. Mitsubishi has a YouTube channel. I would
And some of those come with NATE certification,
Some of their learning.
and you will register for them, and they'll be able to see that you've completed them and all that. So that's good standing for your company, especially if they're diamond dealers.
Right, right. And anything with Mitsubishi, once you register, now you're an official, you're a known entity with your name and your email address. So when it comes time down the road to register for courses, you're already there. So one time, so.
All right, well, thanks, guys. I don't know how many of you are still hanging in with us, but we do appreciate you doing this with us.
Yeah.
And trying to work through this whole pandemic
Right.
and the restrictions that are put on us. But we wanted to be able to give you guys something to be able to do this morning and to sharpen your tools.
Yeah,
To understand the product.
just a taste, we talked, I think we started out by saying, one of the things about learning service on Mitsubishi is you just don't get the opportunity, because they don't break that often. So hopefully now you understand the resources, and we just touched on what's available to you. But just like any other service manuals that may be there, just follow the instructions step by step. So just hopefully you bookmark those sites, and hey, go ahead and look at them, learn.
And hey, guys, also, if there's any questions that you have after this, or you're reading, you're looking, give the number a call here.
Yeah, call us.
Call us and just say, hey, can I talk to one of the guys in support? And they'll give us to either Jim, me,
Mention Mitsubishi.
mention Mitsubishi, you'll get the right guys, and we can answer your questions.
Right. We're here for you. Because quite frankly, things have slowed down a little bit on our phone calls coming in. We've got time. We're glad to talk to you.
If not, I'm running the vacuum, or no, not really.
No, we actually have to put a lot of these presentations together. It's not like we're not doing anything.
But my wife thinks I'm at home to help out.
Oh, yeah, I got that too. Hey, can you help me with, clean up the yard? Well, it's kind of hard to be on the phone and do tech support while you're on your own. So.
Okay, well, thank you very much, guys. We do appreciate it.
Yep.
We'll talk to you
Hope
later.
to see you soon.
Yes.